Now please, these are videos. These are not like your traditional videos. These videos are meant to help you learn and then pass that information on. And basically, we're not going to call the FBI and report you if you share these videos with your friends. So feel free to enjoy the video, pass it along to your friends, and please share the information that I've passed on in this set of videos or individual video is taken me 45 years of modeling to come across. My name is Wendy Ertnowski, and I'm going to try to share with you the information that will allow you to make a very reasonably priced, inexpensive, and kind of fun to make set of landing gear for your next airplane. It'll save weight, be a fraction of the weight of the aluminum counterpart, and be just as strong. So stick around. We're going to try to make a mold and lay up a couple of parts in the next hour or so. Now, as we always do, there's a couple of little prefaces to this tape. Number one, while I'm shooting the video, I don't wear my mask. So let me just right away give you an idea. In the real world, you want to wear your Wilson mask or whatever whenever you're working with carbon fiber or epoxy or paint. Always wear your mask. I can't wear it while I'm shooting video for the simple reason that I just find it impossible to get a nice clear audio. Now, the first step in any project like this is to get an idea. In this case, we're copying right off a cover of Model Aviation, November '98. Just to give an example, the piece of aluminum that normally is comprised to make the landing gear, normally that would be made out of 2024, 6061, or 7075 aluminum. Dural is another trade name for the aluminum. It really is a very efficient way of making the landing gear. It's the way that's used on many real full-size planes. Now, in the world of modeling, a lot of times what the pilot is trying to do, and I would emphasize in pylon racing, in control line, in a lot of the events, in scale, being able to reduce the weight of this part by half is a significant savings that would allow you then to either have a lighter model or put more of the weight into the finish, the cockpit detail, the power plant, the radio, the wheel pants, detailing. The purpose right off the bat is to decide just how much you can save, and roughly, if you use the method I'm going to show, and I'm going to show this in a way that I've experimented with for quite some time now and found very easy to replicate. All products that are available easily commercially. There's no high-tech things that you can't buy in a store. It's all available commercially. Probably available right in your hobby shop, in fact. One of the things, though, is it's always a good idea to have the original part that you want to replace. In this case, to have the aluminum gear. Now, that we're going to use on this video a demonstration of making a control line stunt landing gear. But the same rules would apply, the same techniques, the same technology would apply if you were making a giant quarter scale model, a smaller model, or even in some cases a half A model. You'll always be able to do better than aluminum with carbon. The reason is the material itself, when it's done correctly, is stronger than the aluminum. You're starting with a better quality material, a material that when it's used properly exceeds the strength of aluminum. In this case, one of the things that we've been able to do in the past is cut the weight pretty much in half. I'm sure in bigger and bigger models that may even be more significant of a saving. But again, it's a simple method. We're trying to pass on information here. This is not made to be a cute video where we have models walking in and out with bathing suits on. This is for real hardcore modelers that really want to pick up some good information in a hurry. Now, I'd like to introduce myself to the people who might not have ever seen a Wendy video. A Wendy video, let me back up just a little bit for people that might not know. I started making videos in 1987. The sole purpose of those videos was to share the information that I had learned in my previous modeling life. I've been a modeler for 45 years. I have really enjoyed, and it's been the primary focus of my whole life, to build and fly and share the information. I've made a real life's work of documenting everything that goes on in this shop. I have made 700 plus master videos in the past 11 years. I've also tried to focus in on documenting the control line stunt event, among others, in a way that would make sense, that people could enjoy the videos. You'll notice we don't have any computer generated titling, we don't have any high-tech things that would increase the cost of the video. The purpose of the video, so that we can get this straight right in the beginning, and you might be interested in seeing other videos. The purpose in the very beginning of this is to share information, and I would encourage you to share this tape with your friends. I would encourage you to learn from it and then pass that information on. Now in this case, we're going to be making a carbon fiber gear. I've been working with carbon fiber, making propellers, tune pipes since the early 90s. And one of the things I've learned is that it's a big mistake anytime you want to make a part to make a permanent mold right away. In this case, this is the part that I wanted to replace. This part weighs roughly 60 grams. I went out, made an exact mold of this with balsa wood. It need not be high-tech. And if you're only going to make 1 or 2 parts, if you're not going to go into any extensive producing of the parts, a balsa wood mold will be fine. It'll probably self-destruct in a relatively short time. Pieces of it will come apart. Not necessarily, but it's not a hard enough material to make a permanent mold. What I call a permanent mold is when you're going to make more than 100 parts. But anyway, you can make serviceable parts. What I wanted to do in the very beginning was make up a rough prototype with 2 different types of material that are commercially available in hobby shops. One of them is a material that has the weave going in both directions. That's usually available in 4-ounce cloth. It's relatively expensive. It's about $40 a yard. It's available from several sources, including hobby shops. The resin, when I made this up, I wanted to use a real non-toxic resin. I used West resin, which is available any place that sells boat equipment. Very inexpensive. So when I made the original part, my original thrust was to find out how thick I needed to make the part in carbon relative to the aluminum. So the first test was to make the part, the aluminum was 93 thousandths, I made the part 93 thousandths. Well, the weight saving wasn't as great as I thought. So I redid the mold, the original balsa wood mold, to come up with a part that was a little bit thinner. And this is where it gets to be a little tricky, because you can trade away, you can really get the part to be a lot less than the aluminum if you're willing to make a change in shape. In this case, I want to make a reinforcing rib going right down the part, which is not in the original mold, and then make the whole part even thinner. Now this would work even better on a giant RC scale ship, and it's this part of the job that can get to be a little confusing, and that's why I like to make prototypes up. It's relatively easy to make balsa wood molds. You can make them in a couple of hours, get a part laid up, and get an idea if you're in the ballpark before you spend the intense time of making either a hardwood or a metal mold. If you were going to make thousands of parts, you'd want to make the mold out of aluminum. In a lot of cases, you could make part of the mold the actual part you were going to mold. You could make parts of aluminum if you could solder them, weld them, but we're not going to get into that kind of a thing. We want to make it with hobby shop material that's available in everybody's shop, really, and with carbon fiber tow that's available from Dave Brown Products. It's a commercial thing. It's very inexpensive. It's about $5 a pack. We need roughly 3 packages to make one of these parts. In a bigger part, obviously, you'd need more. The resin, if you buy it, it's roughly $2 an ounce in small quantities, maybe $1 an ounce if you buy larger quantities. But again, the cost of making it is very attractive. Typically, these parts sell for $15, and I'm sure RC parts would be proportional, and you can pretty much make for less or maybe even a little more at the same cost of material. Obviously, the difference is you have to have the mold. So what we're going to do is, from this part, we're going to try to lay up a part that has a thickness of less than 93 thousandths, and we're going to try initially to do it at about 60 thousandths. That should give me about a 50% weight saving over the part I'm already making. And then I want to figure out exactly how I want to make that rib, a strengthening rib, because that'll be part of the engineering that allows this part to get lighter and lighter. Now, yes, you could do that with aluminum, but you'd need to have some kind of a stamp, a press. It would get very involved. The average modeler does not have an aluminum shear to cut this. He wouldn't have access to a punch press or some kind of a bending jig. So to make a carbon part, the beautiful part is if you take one piece out and it's too thin, you can add a little piece to the mold and make the part thicker. And maybe you'd have to make 3 or 4 parts. In our case, we made about a dozen of these so far. You'd have to make several parts before you came up with a totally serviceable part. But the nice part of this is that in the very beginning, it's a very little cash outlay. It's interesting to work with the material. The material is relatively non-toxic, even though I suggest everybody always wear a mask and good ventilation. And it'll allow you to custom tailor that part. You can make thicker ones, thinner ones, wider ones on a very easy, once you see how a mold is made and you get a couple of the little tricks that are involved in this. If you don't have the tricks, and one of the biggest, when you start a molding thing, the biggest thing to understand is when you make a mold, you have to be able to release the part from the mold. If you made the mold out of wood and just laid the fiberglass on the wood, the carbon fiber fiberglass resin would pull a mold apart. It's called a catastrophic lockup when a part destroys the mold in the world of real molding. Now, in my turn of molding parts like this, I've molded propellers, cowlings, exhaust flanges, all kinds of things. I've had a lot of help from Wayne Triven, Dennis Toth have both been very helpful, and Ed Gallagher also, helping me understand how to go about making this mold. And that's the information that I've gotten from other people that I'm pretty much passing on to you in the hope that you'll complete the cycle. You'll then go ahead and make a part, show people, pass the video on, and this will become a part that you can make then, custom make for any model you make that has this type of landing gear. So let me get started with laying up this mold. Now, the original mold to test parts was made of, this is just balsa wood with little plywood edges, so that I could adjust the thickness. If I added or took away some material here, I could fine tune it. I used an ordinary auto primer, Rust-Oleum auto primer, sanded it out. The quality of finish that you put on here will be the quality that comes out in the part, in the finished part. It's very good at picking up little flaws. So again, if you're going to take the part out and totally sand it down and put a finish and paint it to match the model, well, at this point you don't have to be real careful. We also wax 4 coats of mold release wax and 4 coats of PVA, which is just a cheap insurance. Again, this has 2 coats on. I'm going to put another coat on because this allows me to make up little prototype parts. And then once I'm totally satisfied, I can go into making a real, what I'll call a final mold, where all of the edges, all of the angles, everything will be really nicely finished, and the parts should come out totally finished. What I try to do is I set up a little corner of my shop. I call it my molding section. I try to keep all the parts that I would use, all the supplies that you would use in molding, in one handy area, so I'm never lost looking for them. The resin that we're going to use is West System 105 epoxy resin. A can like this is typically about $30. You also need a can of hardener, and you need a set of pumps if you want to use them conveniently. These little, I call them ketchup pumps. These I've had for 3 or 4 years. They've been totally usable, serviceable. I always leave a little cup underneath the pump so it catches it without dripping all over the table, any little extra that comes out. The little ketchup pumps, when you push down one stroke, it meters out exactly the right ratio of resin, and you get a nice, ready to mix little batch of 1 ounce of resin. Usually a part like that would need about 2 ounces, but I mix 1 ounce at a time. There's 100 different kind of release agents that have silicone, some have no silicone, and I have tried them all. Other resins that have worked good are the ones from Florida Glue Products. We've used those. Those are a 2-to-1 mix. The reason we're using the West Systems resin is we just happen to have a gallon of it handy, and we've been doing all our prototyping with it. But the epoxy resin is a big part of it. I would suggest you not use any polyester resin, but that you stay with an epoxy resin. The West Systems is good. If you feel in the beginning you're going to want to take a little extra time, they make a slow hardener and a fast hardener. The fast hardener would be if you want to work in production and try to get these parts to cure as fast as possible. For an average modeler, it's just as good just to have the slow resin and let it cure overnight. Overnight, take the part out in the morning and it's never a problem. Now we could make an exotic silicone rubber mold, an RTV rubber mold, and we've done that in the past. We have molds here. This gets very expensive. The reason we're trying to use a system that would be duplicatable and repeatable for the average modeler. So we're going to stay away from the rubber for now. PVA is very inexpensive. You can buy this from Florida Glue Products, and at the end of this tape I'll put all the addresses on that I maybe have left off. They sell resin, they sell the materials you need. Aerospace Composites, George Spar is another source, good source of resin and parts he's supplied me in the past. But the PVA is one of the things that we're going to use. It's a good, inexpensive release agent. You're also going to want to have something like Formula 5 release wax. It's really pure carnauba wax. That's what we use. We wax the mold when it's completely finished. We polish it, put 4 coats of this on an hour apart, let it dry. Also at the end of it, then roughly an hour apart, brush on or spray on. A spray will give you a nicer finish. 4 coats of PVA, and then we're ready to lay up the mold. We're ready to lay the carbon and the epoxy into the mold. And this, if you do this religiously, you can probably get quite a few pulls out of the mold without having to re-wax it. But you do have to redo the PVA every time you use the mold. Now I want to get Florida Glue Products since they've supplied a lot of our materials, and they are really a good source of material and technical help if you need it, if you're laying up parts. Ed Gallagher was the one that set up my little contact at Florida Glue, and they have really, really been as helpful as you could ever expect somebody to be. Another person, it's an excellent source of all of the things you would need, and good to just get a catalog from George Spar at Aerospace Composites. These people, by the way, in Aerospace Composite are basically doing glider wings and have really high-tech vacuum bagging supplies. Their catalog is excellent to have. The source of the carbon fiber tape, again, Dave Brown Products. This is usually an off-the-shelf. Every hobby shop would have this on the shelf, or you could call Dave Brown Products. You also have on the back little tips on how to use the product. This would be very helpful if this was your first time using carbon fiber, to read the instructions on the back. But if you're doing your first layup, this is a good quality material, very easy to handle for your first layup. I buy tow in giant rolls like this, but see, the purpose of doing this is to keep the part inexpensive. A roll of material like this is a couple of thousand feet. This is really getting expensive. Average person wouldn't want to do this. That's why I suggest if you're going to only do 1 or 2 of these, good idea is to use the Dave Brown part, the Dave Brown tow. First step in this whole process, I'm going to take some 1/4-inch balsa wood and just lay out the internal shape that I'm looking for. Again, I'm going to need to make this. You can use scrap wood. You need not even use a good piece of wood. Just roughly get that shape. I'm going to have to add a little piece up here. Get this trimmed out on a jigsaw so that I'm going to wind up with 2 ribs that basically will comprise the inner shape of the mold. One of the things I always encourage people that work in a shop to do is replace. We use XL blades exclusively, and one of the things I always encourage people to do is replace the blade so you get nice clean cuts. On a mold, this is real important. You don't want to have all kind of areas you have to fill in. A new blade, once it starts showing signs of crushing the wood, just replace it. I need to just tack glue this part on here and then trace the part up here so that I wind up with 2 profiles. Again, if you were building a giant scale plane, you would just make these parts maybe out of 3/8. In this case, I'm just using up some 1/4-inch wood that I have in the shop. Now obviously next step is to replicate this part so we have 2 the same. Good idea to always use a fine line pen too. Tends to make a little bit nicer line on the wood. Again, I can't emphasize enough, sharp blades. Score it, second cut through, cut all the way through. When going end grain, you might want to use a little saw, but if you're replacing the blades, you'll always get nice clean cuts. The thing is just to get the two pieces held together. Usually this is kind of easy, and we'll just get them what I call a mirror image so that they're exactly the same, even by the thickness of a pencil line. What I want to do is using one of these pieces, get the length on here, transpose over a 90-degree angle, and this will be the base plate for the mold. Again, all of this is materials you should have right in the shop. Should be nothing even have to run out to any exotic parts store. The problem with using exotic materials is a lot of time you can't buy them in small quantities. You can't buy them conveniently. I just want to, for this purpose, just want to put a little tack of glue on this. I want to tack this all up before I make any permanent glue joints. It's easier just to tack things together before you make any permanent joints. You get everything just the way you want it. Now the next step is to get all the edges trued off and make sure everything is exactly the same. I don't want to have these offset one way or the other. Kind of important to keep that, otherwise the gear would have a wave in it. Again, what this does, it lets all the joints be as true as possible. Sure that we have two mirror images and that they're right in line with each other, 90 degrees in all the dimensions that are going to matter. Next thing here is I want to measure the dimension between the two parts. Make sure it's accurate. And I want to get some 1/4 inch wood stripped so that I can fill in, and this will become a solid piece. A nice 48-inch straight edge is good for doing this, but I want to make sure I have a piece of wood that the grain isn't sprung on. Start with the end pieces first, keep everything 90 degrees. Now I want to get a nice dovetail joint on this, a nice angle joint, so it's easy to do with the belt sander. What I try to do is I just rough this out, do the final little bit by hand. I need to get about that angle on there. See, I need a little bit more, a little bit more. Side off camera and then just top fit this top piece just like a cork. To do this piece is simply to make a piece that's oversized, put the angles on and just let it be like a cork, where the angles, it just fits in like a plug. Everybody gets the idea. Just trim this down with that angle on there, and that angle will let it just drop right in. Now one of the things we had to do is just put a little radius in each corner, and I want to get the radius roughly the same as on the piece of aluminum. Doesn't have to be totally exactly the same, but close would be good. I take 64th plywood with the grain going this way. If I put the grain this way, it's not going to want to make the bends nice. And I want to just trace out the width. Roughly, I'll leave it a little bit oversized maybe, and then just trim it in. Final trimming by hand on the belt sander, but I want to get that width. When you use this, you notice one side is usually a little smoother than the other, so of course we'll put the smooth side up. Also, I wouldn't want to wrap this around and have the joint out here. I'd like to get the joint right in the middle, so I'll make two of these pieces and then just let it lap over. Tack glue it in. Remember, this whole thing is just tack glued together. I want to make sure I can wrap this completely around. I want to do one side at a time. If I glue this side and this side, what's going to happen? I'll have a bubble. I want to wrap this around carefully, let that side dry, wrap that side around carefully. So I'll have a complete veneer of 64th plywood on the mold. Sides glued. Just a question of bringing it down onto the table, nice and square. Let it kick off. Okay, now just repeat this on the other side, and then we'll go final trim this down, and that'll be the base part of our plug. Again, roughly $5 worth of material in about an hour of time, maybe an hour and a half. Sand this down, I can get full glue joints around all the edges. Now we know we have it in one piece. I just wipe all the seams with a Q-tip. Cut these extra areas out. Just give me less to do on a belt sander. Again, if you didn't have a belt sander, there'd be no reason you couldn't do this with a block of wood, some sticky back sandpaper. To have here these are available from the Woodworkers Supply House, various grades. And what they do, they have a little mitt, a little rubber mitt. I like to use this whenever I'm making a mold. Totally keeps you away from getting uneven edges. And since we're just dressing this down, it has a little paddle in your back. Basically, this is the male part of the plug. Get this up off the table, so I'm going to glue this to a base. First I'll trim the piece of wood, just so I have a little runoff. At the end of my legs, I'd like to be able to drape the carbon back down over it. So what I'll do is make up this base, glue it right to the bottom of the plug. I don't really need a killer glue seam here. I just need to get this to be part of the mold. I can really just go true this all up on the belt sander, and that gives me 1/4 of an inch of runoff when I drape my carbon down over the edge. Alright, that's all trimmed up. Now we got to lay up the gear. Use tape, colored tape, masking tape, anything, so I can vary the gear shape. Remember, I'm trying to make a slight modification to the aluminum gear. I want to have a little bit different shape, and the tape allows me to go back and forth and vary the thicknesses. I want to make this a little bit thicker at the bottom, a little bit thinner at the top to start with than the aluminum part. And I can move the tape back and forth here. I can just pen in a line. Give me a starting point, run my finger right down the tape. This is nothing permanent yet. This lets me look at the rough shaping that I'm going to have here. Nothing here is permanent yet. Really satisfied I can pen in all the lines with a permanent line. Still making any small changes I want to. A nice dark line on there, a little scratch even in the wood. Tape right down the center, roughly the center. And I want to just scribe a very light line on here. This is what I'm going to call my, for lack of a better word, a reinforcing rib. I want this to be right down the center, so with a machinist ruler, before I scribe this out, I can make sure I have it pretty much where I want it. I like it to be going pretty much right down the center. Using the green tape, I've kind of laid out, because we have a constant taper, so none of this really follows suit. We want to get a constant taper in that. And right there's where I want to put my little reinforcing rib. Now I'm going to have to take the blue tape out and scribe the inside edge of this tape to make the next line. What I can do is with a Dremel tool I can start taking out that material little by little by little until I see how thick of what thickness I'm going to try for as far as the reinforcing rib goes. Now whenever I do a video I try to show some of the tools that have been real helpful to me. In this case I have the Dremel tool hanging over a vacuum bench. There's a vacuum that pulls the dust right out of here, and because we're working in the cellar of a house. It's a real powerful motor. I've written a full article for Model Aviation on how to make this, and I have a video on how to make it. It basically comes through here, goes through a 4-inch stovepipe, out into here and into this giant vacuum bag that keeps a lot of the dust right out of the house. So it's really a handy tool. And I always try to show these things. These are things a lot of modelers don't really know about. It's about a $300 tool, but if you're going to work in your house, it'll keep the whole area relatively dust-free for the whole time you're building. You can do all your sanding over this, and when I shut the door to this room stays almost totally dust-free. Got to rough in between here and rough out a little bit of what I hope will be a reinforcing rib, and this will allow me to make the overall part even thinner. Ball cutter, I want to scribe a line right down the center of the part. Now it doesn't have to be fancy. It doesn't even have to be on center. That just gives me a starting spot to put my big cutter in. Step is just a sanding drum, an ordinary sanding drum. I work my way right up to the tape, little by little. That little trough just starts to take shape. I try to go out into the tape the same distance on both sides. I can see here, for instance, that I'm wandering to the back, so I can kind of favor this side. Sand out there's all kind of rubber shapes you can buy, polywog shapes, all kinds of things. What I want to do though, just back to basics, a piece of carved leading edge, a piece of sticky back sandpaper, and I can rotate paper from time to time. This will give me a real good tool to start working that edge in. Now we could change the shape or the diameter, the radius, just by changing the sandpaper. The reason I have the tape is I'm working toward the side of the tape that's getting the thinnest. I can see the back of this is getting a little thinner, so I'll kind of put pressure toward the front. That tape helps me keep everything centered. Now if you don't have one of these mechanical tools, this is a Porter cable. What these have that's real nice are these little sanding shapes, and what I'm going to try to do to put a final finish on this is find the one that looks like it's got about the right radius. That one's too small. That one's too big. I'll do the small one. Use sticky back sandpaper on this. This mounts right on here. It goes right into the Porter cable tool. And it'll allow me to get that groove real nice without much effort at all. These in the shop, again, obviously you can just finish off by hand, but having this really adds a dimension to the finishing of any molds. Again, real easy to use. If you're not familiar with it, practice on a piece of scrap. Any spot where we go through, we're just going to plug it up with a scrap piece of balsa. I'm using the tape as a guideline again. Again, a very handy tool. A little patch for this, just fill that right in. And one of the things I always show on my videos are the mistakes and what's possible. Now this is just a little cork. I made a little reverse cut, tap that in, but drop a CA. I can trim that and sand it right off. And it looks like we're getting thin here, but we're going to seal this with thin CA real soon. Let me just sand this back down. That's a good way to patch any place you have a hole. Pretty much get rid of this. Get a couple of coats of thin CA down into the raw balsa just to harden it up before we go on to the next step. Those first coats of thin CA will really just soak right in. When you rub it with a Q-tip, don't use any kicker. The dust from the Q-tip acts as the kicker, and you get it sealed in 1 or 2 shots. It doesn't really matter how many times you sand through and you pick up little high spots. The trick is just to get the whole thing covered, so in the end it's all got a little bit of a gloss to it. Then you know you're sealed. You go back through, pick up the high spots, so you're actually using this almost like a filler coat. And again, no kicker. Just want to take a good old-fashioned Q-tips. This seals the edges up too, so that the primer, when it goes on there, will have a nice smooth surface to grip onto. Now I just wiped on a real thin coat of epoxy. I'm going to let this dry overnight, then sand it out. I want to see it get a little bit of a seal on a wood before I put the edges on, and that should do it. The reason for that is then I can sand in here without running up on the edges so easily. But that was a pretty good start for one day. Tomorrow we'll get back and work on this. Today what I did, I waited for that the epoxy coat to dry overnight, and I put on several, I want to get this up on the camera, several coats of thick CA on here. And the purpose of this is I just want to build up a coat so there's no grain showing. I'm using it almost like filler to make a hard surface. I don't want to have any imperfections, and I want to final sand this out using some fine sandpaper before I put the edges on. I'm getting a nice smooth finish, so there's just one final coat of thin CA on that when I'm all done. And I've been wiping it with Q-tips. Whatever spot I sand through, just go right back and do it again. And you can see it leaves kind of a shiny surface. Once that's sanded out, that'll be a good base for our primer coats. He uses a little wood sanding block backed up with some sticky back sandpaper. Use the vacuum. In fact, it's getting warmer outside now. I'm going to try to do some of the sanding outside just to get some fresh air. As you can see, you just need to get so you have no shiny spots. The shiny spots show you where the low spots are. So as soon as you can go down into it, you know you have a pretty hard finish then. And then that would be ready to put the edges on. And just to see how quickly that one came right up. This one you can see the shiny imperfections. This one is a pretty good flat base now. It's such a nice sunny day out here. We're going to go out by the pond and just do some, see how nice that fits right in there? But the trick will be when we're all done is to have no shiny spots. The CA where it's shiny, it means you need to fill that down or sand down into it. And it's this part, because the epoxy resin will pick up every imperfection in a mold. The fancier you make it, the nicer, the smoother, the better all around it's going to be. And assuming you're looking for perfection, this part of the job usually will take quite a little bit of time, is to get that nice smooth finish on everything. Doing a lot of this work outside too is you don't have to wear a mask or breathe in the fumes. I can just get the wind blowing at my back, and that's the direction I'm trying to sand in. But it just makes a job that can be tedious and boring, and this is a part of the job that just takes a little bit more than average time, because again, every little imperfection you leave in here is going to come out in the final part. And if I do have any little low spots, I'm just going to go back, put another coat of thin CA on them. You get an idea how nice the final sand out of the CA is. Now we're ready to put the edges on. What I need to do is strip some 64th plywood, because I want to be able to bend it up with the grain going front to back. And no matter where I have to put the joints, I want to bury the joints so that they'll overlap. And go right down and make this shape on both sides, the thickness that I want the ultimate gear to be. In this case, I want to start with roughly 60 thousandths, a 1/16 of an inch. The reason being, I think this reinforcing rib is going to add so much strength that I'll be able to get away with making a thinner part. Now if I can't, all I'll need to do is sand this off and add one more piece of 64th until I get the ultimate thickness that I want to have. But I'll start off with a 1/16 around the whole perimeter. Choices you have, of course, if you have longer pieces, we could do this all, one side anyway, all in one piece, but we can put lap joints in it, it won't matter. But I just want to show that if you try to bend it with the grain, there's 3 grains and 2 are going in one direction, but the other way it bends around circles. So obviously we want to get a real straight edge on the belt sander. I want to use a ruler to cut it and then trim it on a belt sander so that we get a real nice edge as we start laminating up that edge. Handy for cutting, if you're going to do a lot of cutting, is one of these XL cutting pads. It saves a lot of wear and tear on the blades. You get 10 times the amount of cutting out of a blade, but 64th plywood, if you weren't looking for a perfectly straight edge, you could even cut it with a pair of scissors. I like to get this over on a belt sander and get the edge that we're going to use really perfectly straight. It's usually easier to start somewhere in the middle and bend both ends down than start at one end and walk your way up. Now the next time I make a joint, I'll put the joint so they'll always be staggered, just like in furniture. What I did, I took some sticky back paper on one of these, I don't know what you call them, pollywogs, tadpoles, and I want to dress that edge off before I put the other edge on, because what I can do is lay this in. I won't be able to do that to the other edge. This edge is a perfectly flat edge, and get right in there and dress that right off. And then of course I did 3 layers. I'll repeat the same thing off camera on the other side, and this will be pretty much ready to get the final finish on. Next step after this is all tidied up is, and this is a good trick you can even use in modeling. Take some thin CA, take a paper towel, don't let it get stuck, rub it real quick. It gets on and as it starts to kick, get the paper towel out of there. And what it is, you just get a very thin veneer of CA on there. That takes a very light sanding, and this will be ready to prime. At this point, it's all sanded real nice, very nice and clean, smooth as possible. You have a lot of choices now. One thing, you could use auto primer. That'll dry in about 15 minutes. And you can sand it, put another coat on, sand it 3 or 4 times, and that'll pretty much give you a nice surface. But what I want to try is the new product that's just out on the market, Brodac Dope. Butyrate dope with a little bit of retarder. It'll get a good penetration, and I want to see on this mold especially, I want to see just how smooth I can get that finish. Now one of the nice things about Brodac Dope is 20 minutes after using it you can buff it out. But the problem here is I'm running out of time for this session, and what I want to do is put on 1 or 2 coats an hour apart and just let it sit like this overnight. Now this is normally used to finish models, finish real airplanes. Goes on real nice and smooth. If you're going to use it as a mold base, it's a good idea to use a little bit of retarder in it. That'll let you get a little bit longer work life before it kicks off, dries out. You can get all the brush marks out. When it's done, it'll be very little work. You can see how nice this is a premier dope finish, and it lays out beautifully. 2 or 3 coats should be all I need, brushed on. Now put the first coat out. I'll let this dry overnight and come back and work on this tomorrow. You just want to get all the brush strokes out before you put it out to dry. Today I just checked over the whole mold to see if there's any runs. It looks like we have a pretty clean drying. Now the reason I chose Brodac Dope to seal this with is it polishes up to a very high gloss really within 24 hours, sometimes less than that. I'm using 1200 sandpaper, and this is the part of the job that can be a little labor intensive. But it's the same, basically the same technique you would use to polish a model plane. I'm using M600, but you could use soapy water. This is Sikkens M600. And I'm just going to get down in there and put a high sheen on all the parts. This makes for a nicer part and also makes the release of the part almost a guarantee rather than just a maybe. When you have a very rough part, the epoxy gets more of a tooth, and sometimes releasing can be a problem. Now I don't want to sand all of the material off. You could use 4-0 steel wool here, or any choice of materials. And we're going to do the final buffing with a product called Gorham Silver Polish. Now I sell that, but it's available in grocery stores. Some parts of the country don't have it. If you need some, you can always contact me. Now my address and all the addresses of the sources, of course, will be at the end of the tape before we conclude this. And what you want to do, and I wanted to show this, this is the part that a lot of people might want to improve their skills on, is to get that as nice and flat as possible. Because the next step after that's sanded out is going to be to get some Gorham Silver Polish and get that to a very high luster, a very high sheen. And as with any chemicals, any epoxies, you want to have good ventilation. And like I said in the beginning of the tape, if we weren't in a video producing session right now, what I would be doing is wearing a mask, and possibly even if you're comfortable with rubber gloves, they can be handy. This part of the job though is very difficult to get in, for me anyway, when I'm using rubber gloves. But it's basically a polishing technique. So again, you want to get the surface dull and flat. If you need to use little sanding shapes, may want to get in there a little bit more, but I want to get the surface that's actually going to be part of the final part to be a very high polished surface. And you could do this using other materials, auto primers, lacquers, epoxies, but it just turns out that this material really has proven to be very superior in working this kind of a mold to get that smooth surface. I haven't found anything that beats Brodach Dope yet. Now you want to keep in mind, if you are in doubt about any of the finishing operations, I have many videos on finishing that may be a big help to you. George Spar has some excellent videos that you might want to check out. John Brodach sells a complete line of videos. All these videos are made so that you can pick up some of these skills. Now in this case we're doing corners and edges. The more time you put into getting this plug really nice, because once you do it, see, if you've never made a mold before, this part of it seems real tedious and you say, oh boy, gee, I'm taking all day to work on this, it's taking me a week to make a mold, and gee, but once you're done, you can replicate these parts, you can replicate them for your friends, you can replicate them and basically barter, trade, sell, whatever. But then you've acquired a skill that you can add to your modeling, and parts that wheel pants, cowlings, canopies. We have videos on doing all of that. Rubber molding, hard shell molding. And there's going to be more coming, so always check with myself, check with George Spar if you're interested in any kind of molding. George Spar is an excellent source of technical information, help, and he's a modeler. See, that's the part that really helps. He knows what you need. As I said, I've been in the paint business for 45 years. I have never found anything that will buff out any kind of lacquer better than Gorham's. This is Gorham Silver Polish, typically available in grocery stores in some parts of the country, certainly not everywhere. And what you want to do with this is a clean paper towel. You want to get in there and very carefully, the same way as if you were buffing out the paint on the outer shell of a model. Because once this is buffed out, you'll be able to make many parts. And each one of those parts will have that smooth glass-like surface. This is a part that's probably going to take a little bit of time for me to do. I'm not going to belabor it on camera. Again, there's many videos available on how to buff paint. We certainly don't want to tie up too much time on this, but getting that surface as perfect as possible, because that is going to come out in the final product whenever you make a mold. And it doesn't matter what material you make the mold out of. You can make it a hard shell mold, you can make a rubber mold, whatever. But the polishing of this part is really important if you want to have really nice parts. And that's the beauty of the Brodach Dope, is how easily and beautifully it buffs out. And obviously it's real good for finishing a model too. But for a mold, it really puts that glass-like finish on in a couple of coats and can be buffed out the next day. A really good trick, a lot of modelers don't even know you can do this, is not even to use a paper towel, just to use the edge of a piece of soft balsa wood that fits into that cavity as a polishing agent and rotate it. That's a good way to get a nice shine on a part that obviously would be a problem to squeeze your finger in there, but you can get a good buffing, a good polishing right in there. Soft piece of balsa wood. And, you know, the beautiful thing about mold making is once you pick up most of the basic techniques of making any mold, there's so many different ways. It's a whole new way of modeling. It adds a real dimension that's fun, and it's replicatable. And it's not like if we built one landing gear and we're all done, now we have to start building another one. Once we make this mold, we really will be able to make a real big quantity of these. So it's really time well spent putting in all the polishing and detailing of a mold, especially at this time. This is the time everybody wants to hurry up get done, put the extra time into the polishing operation. You can see how that's polishing up real nice. Step is to get some pure carnauba wax. This is sold as mold release wax, very high quality. If you can, get pure carnauba. And what you want to do is put 3 or 4 coats. I like to put 4 coats. Let each coat dry. See, it just flakes right off. Put it on, let it dry a few minutes. By the way, a good tip is to have an old sock available. This is a great time to use an old sock during any polishing operation. I want to get at least 4 coats on, 1 hour apart, and let each coat dry. The trick is not to rush this part of it, because if you have what's called a catastrophic lockup, that part will stick to the mold and destroy the mold as you try to pull it out. So this part is extremely important, and you don't want to skip it or chimp. Now what I'll do is, I'll do an hour apart, 4 coats, and then I'll be ready to spray my release agent on. But this is one part that actually adds to the polishing and smooth finish. You want to rub it in, buff it in, let it dry 4 or 5 minutes, and buff it out with the dry part of the sock until you have a really, really high gloss shine. The whole trick is to get it at this point in time, get it as high gloss as possible. Okay, that's the first of 4 coats. You notice I even went around here. Got plenty of wax because some of that resin will drip around when we lay up the mold. Getting that finish, so important. Probably the most important step of the whole mold making process. And that Brodac dope really makes it easy. PVA, polyvinyl alcohol, is one of many release agents you can use. In this molding technique, I like to use about 4 coats. Let each coat dry individually. You can spray it on. If you spray it on, spray it at real high pressure. In this case, we'll brush it on. It won't really matter, and the final result is the mold is polished enough. We should get a real nice final shine, because don't forget, you really will be picking up in the final part the surface of the PVA, so you don't want to have a run, a brush stroke. If you do it, put it on in thin coats. Don't try to put it on in big thick coats, globby coats, and try not to get a run. It's not a good idea either, I've found, to try to force dry it with a hairdryer. Just let it dry at room temperature. Make sure you're not getting a run in it. 4 coats later, well, we probably won't finish this today, but 4 coats later, we'll be ready to lay up the mold. All right, the first step, once that PVA is cured and dried, today I want to tape some newspaper to the table. That gives you a big help, because once everything seems to start to get sticky, including your fingertips, and you touch things and it pulls it up, it's a real good idea. Tape the newspaper down in as many places as possible. It's a good idea to work over newspaper, needless to say, unless you like cleaning up. You want to cut all the toe ahead of time. Now, I got a roll of this from George Spar, and I've cut it into pieces that are just long enough, and leave about 1 inch on each side extra to give you some room to pull down on and put tension on the mold. Well, good idea to cut all your toe ahead of time, and I always cut some extra just to make sure I don't get to the end and then my fingers usually have a little bit of stickiness to them, and I go to cut it and it makes a mess. I have some thin toe, and I have some thick toe, some 1-inch toe. So I want to fill the mold. The idea is to get as much toe and as little resin into the mix, with the resin just holding the toe together. If you have that concept in mind, you don't want to fill a mold with resin, you want to fill a mold with toe and just have really the smallest amount of resin between the strands and fibers. That's an important concept to have. In an all-perfect world, you'd have on an aircraft part about 52% of the total weight of the part would be carbon, 48% would be resin when it's done really to military spec. Obviously, we're going to try to get as close to that as we can, but within the realm of a hobby, well, making of your own parts for non-B-52s. Okay, so we got all the toe ready. The resin is mixed. We're ready to start laying up the, and again, with the resin, use exactly the instructions that come with the resin. Don't try to deviate from that even a little bit. First thing is we want to find there's several ways to hold our plug in place. This part of the mold is called a plug. First part is a gallon can makes a nice heavy piece because we're going to want to put tension on this. So I want to kind of center this, get a couple of drops of Brodax CA on here, center it out, and that'll hold that in place for the time that we're actually laying up the mold. Again, nothing fancy about this, but you have to have a way of confining the mold. And I don't want to make it permanent at the end of the job. I want to be able to break it free. Okay, that's nice and solid. I want to position this so it's convenient and comfortable to work on. I don't want to have it that you have to individually figure out a way, because what's going to happen is at some point in time your fingers get a little bit of epoxy on them and then everything you touch is a problem. So you really like to keep this work area as neat as possible at this point in time. What's about mixing any epoxy? Each resin system is going to be just a little bit different. You want to go exactly by the directions on that resin system, the mix ratio, and my own personal feeling is, like, when I want to work in a shop here, what I want to try to do is keep the temperature as cool as possible. I try to keep it under 60 degrees. What that does, it gives me a little bit of extra work time. If you're doing this for the first time, you don't want to get a fast hardener. You'd like to get something that's going to give you 45 minutes or an hour of work time. And it's always good to practice on inexpensive materials before you go buy in some resin systems that can cost $40, $50. You can make serviceable parts with inexpensive resin for practice. If you're going to make anything like a propeller, well, then you're going to need some real high-end resin. If you're going to make tune pipes, you need a high-temperature resin. There's a million different kinds of resin, and it's very important to go by exactly what the instructions say. The ratios. My personal little tip too is, when you think the resin is mixed, look at your watch and mix it for 2 minutes more. Don't mix it so fast that you make a milkshake out of it with air bubbles. As soon as I see air bubbles, I see some now, I know I'm going just a little bit too fast and I want to back off just a little bit. But I want to give myself plenty of time on the mix. I don't want to skimp on the mix time. That's always a mistake. Always a problem, because the material that sits along the walls and along the edges can be not totally mixed, and it can screw up the dry time. Now let me get all my toe ready in position, and this will be ready to start a layup. The first thing I want to do is just paint on a coat, a nice thin coat into all the areas that we want to have the finished part on. Now if you're doing a complex shaped part, a cowling with a lot of scoops and ridges, what is a typical way of doing it is to mix in a filler material like Cabasil, Q-Cells. There are many filler materials, and again, this is why you like to do a little experimenting. In this case, because it's not a complex shaped part, we really don't need any fillers. Fillers really don't add any strength to a part, and in this case what we're looking for is to make this part roughly half the weight of the equivalent aluminum part, but also make it as bulletproof as possible. Part of that advantage is going to come from the engineering and having that little recessed piece rather than a flat shape. Part of it is going to come from doing a lot of experiments with different materials and resins to get the most appropriate one for this. And it's the same as when I've made propellers and carbon fiber tuned pipes. The resin system and getting a few practice parts done is really an important part of it. It just gets you familiar with the characteristics of the mold too. Now, one thin coat is all that we're going to need. Again, we're trying to keep the resin to a minimum, the carbon to a maximum. Now, this is another little trick. You have to find some place to put this where it's convenient, because this, by filling our little trough here with some thin tow, each time I put 1 or 2 in. The idea is to keep your fingertips out of the epoxy. And you can be sure by the end of this, mine will be good and greasy. You could use the 1-inch toe, but I just think this will give a little bit nicer fill. Each mold is going to be just a little bit different. Again, I don't want to put so much in here that then I can't get the resin to seep through. And each Each one I want to compress and press out as much of the resin as possible. Now once you have it all compressed out, add another layer of resin so that you get the minimum amount of resin. You don't want to have a big spot right in the middle of it in the core that's dry, and you want to press down. Put a reasonable amount of pressure on that. It squeezes out all the resin. That's the whole trick to getting lightweight parts. Get rid of the resin. Again, this is a little time consuming. People think that parts like this get molded up in a matter of a couple of seconds. They don't. It takes time to hand lay up a part and do it properly. And keep building that ratio. Build on that idea that you're going to get rid of is squeeze out, so you can see the resin squeezing out right now as I pull. Each time I put one of the strands in, I press down on it. Now this kind of toe is called unidirectional strength. What that means is all of the strength is in one dimension. Unlike e-glass cloth, fiber, what you would commonly believe to be fiberglass cloth, the strength goes in two different dimensions. This is going to have the maximum strength in the dimension that we want it to. Now what I need to do is always start at the middle and work down. Always work from the center of a mold out toward the edges. Now I'm going to plan on in the near future making a whole series of different parts that we've already molded in the shop but we've never documented. The tune pipes are an excellent one. Again, a lot of these are specialty parts, but the gear is almost a universal, has a universal application. Almost everybody that has a plane would like to cut the weight of that gear in half. Start laying in some of the wide 1-inch, this is 1-inch toe. Again, we want to fill as much of this. Leave the little oversized to give you some handles to pull down. Again, you want to start in the center. Draw the brush right off the end. Otherwise, you're going to catch little strands of carbon and it's going to turn into a rat's nest on you. Go right off the end of the part. Don't ever go backwards. Never go from the ends to the middle, where you wind up picking up all, especially if you're making this kind of a part or a propeller, you just go crazy with those little extra strands. Now this is why you want to have all the material pre-cut, because from this point on you really have to load. There's about 75 feet of material go into a mold like this, and to stop right now and cut it individually would make you crazy. Now you want to trowel out and squeeze out as much of the resin as possible. Squeezing down, pack it into the mold. You can see how it trowels right off. Resin is squeezed out. I take a material called bleeder cloth. Lay it right over the part. Put just a little bit of pressure on it and you'll see the material come bleeding through. See how the material bleeds right through, and we want to put some tension on this now. And then trowel this back and forth. This will leave a nice finished surface. Otherwise we would need another half of the mold. Again, this is the part where you have to kind of really move right along, because by now the resin is starting to go into a state of jello-like consistency, and I want to trowel. You can see I can, with this bleeder cloth, I can get rid of any air bubbles. I can squeeze out, each time I'm squeezing out more and more resin, putting pressure on that part. And then we're going to use the tails of the bleeder cloth to confine this and squeeze it even more. So this is a very important step. Just take your time, get rid of every air pocket, every air bubble. Bleeder cloth is something that's commercially available. It's used exactly for this application, and when you pull this off, it'll just leave a perfect surface there no matter how much of this resin bleeds through. The trick is, and of course we want to keep our hands relatively clean, is using the tails. Let this put a little bit of pressure on that as you pull down. Full gallons, of course, work well for this. You want to let the gallon itself pull down. You'll see even more resin will come out at that time. Squeeze them together. Just the pressure of putting the cans there is pulling on that bleeder cloth. Now I can trowel off even a little more resin. Now in these little areas where I can't really get in with a trowel, I used these Body Shop spatulas. Use an ordinary Body Shop spatula when I'm all done, and that puts even more pressure. It just adds another. Each time I put pressure on this, the more pressure I can put on this, the more resin I'm going to be able to squeeze out of that part. Almost like vacuum bagging would do, but without the complexity of vacuum bagging. The thing is to just sink some of these plastic wedges down, and this puts even more pressure on it and gives us a nice flat pressure surface there. Again, these wedges, they're just ordinary Body Shop wedges, squeegees. The more pressure you can put on this part, the better right now. Okay, then the next step is just to let this part cure out. Now, because we're already in production on parts similar to this, what we do is we work on one mold on one side while one is curing. I can work on the other one, and then as soon as one part is ready, usually if you're new at this, let it sit 24 hours, demold the part, and then you need to prep the mold again, the wax, the PVA, whatever combination of things, and that would vary by the system you're using. But a safe way is to re-wax the mold. A new mold, a green mold, needs waxing and PVA prepping several times before it releases the parts nice and consistently. So this will have to sit now 24 hours. You're done. Usually, obviously, you can get rid of all the newspaper right away. I like to get it out of the shop. It just winds up making a mess. It's an extra smell, extra fumes you don't have to inhale. Get rid of it, get it out of the shop immediately. Now, another couple of tips. No matter what resin system you're working with, actually anytime you work with epoxy, you're always tempted to take alcohol or acetone to clean your hands. It's really not a good idea. Epoxy can be absorbed through the skin, and the acetone thins it enough that makes that even more possible. So I like, as soon as I'm done with one of these layups or any using of epoxy, lava soap. I have a little hand brush, and try to avoid using acetone, lacquer thinners, anything that would allow the epoxy to penetrate the skin even more. Lava soap is especially good at this. This tip alone will really save you a lot of aggravation. Now, some people are allergic to the epoxy fumes. In my case, it's always a good idea. I try to have a fan going, have a door open. Don't work in a confined area. If you have heat on a shop that has air heat and it goes into your house, obviously this is common sense. You wouldn't want to have the fumes going into the heater and up through the house. And best of all, if you have a garage The advantage of using a garage, the temperature will usually be lower. It'll give you a lot more work time. Now, it's always good to let the part sit at least 24 hours. I've already pulled off the top layer of this. And this is the moment of truth. I got to take a break here and let you know how many times when I started molding, and this was 4 or 5 years ago, hobby related molding, I'd get right to this point in time and I'd try to think of excuses not to come and take the part out of the mold, because in the past, if you don't have the mold prepped correctly, what'll typically happen is you have what's called a catastrophic lockup. That means the part is now part of the mold and you can never get it out. Now, I've made several parts in this mold already, and what typically happens is the more you use a mold, the easier the parts release. A new mold is the most prone to locking up of any. Now, since I've already used this mold a few times off camera just to make sure we were going to be able to get viable parts out, this point in time is a very significant time. You want to get the part out. I always like to let it sit 24 hours. If you're in a production of trying to make part after part after part, there's always a time window during which the epoxy is hard enough. And the person to speak to about this kind of technical stuff is George Spar from Aerospace Composites. There's a time window when the material is hard enough that you can pull it out of the mold. In this case, I know this mold is releasing properly already. And what you can see here has happened is we have a really nice finish. You have what's called flashing from the material squashing out over the edges. And we're going to have to trim this on a saw, do a little bit of hand finishing, check that we're in the weight parameter that we've set for this part. And if we're not, try to figure out why so that we can go back and either add more toe. What would typically happen if we're over our weight parameter, I'll know that too much of the part is resin and not enough is toe. And again, there's that 52-48 relationship that we're looking for. In the case of the past couple of molds that I've made like this, and I've done this for a long time now, I have a pretty good feel for just how much can go into a mold. Now typically the parts that we made on the original mold didn't have the reinforcing rib. These were the same weight, but just not quite as stiff, and this is why any molding project that you do, usually the object of everything is to make one part as reasonably as possible without putting a lot of time and energy or money into the mold, to see if the part that you've created is the right weight. For instance, if this part was already too heavy, then we have to change the design. Or if at the same time, if you've met all the other requirements, is it stiff enough? Can you take one out to the field, fly it, see if you can break it? And since in this case we're trying to make parts for things that, like pylon racers, giant RC scale planes, and control line stunt planes, each mold that we make will be just a little bit different and have a little bit different requirements than the others. They're all unique parts. Talk about, this is a good time, is the evolutionary process of a part. The original part that I wanted to make was a complete replication of the flat aluminum part. And what I did is several times is take material off the high side of the mold, see just how thin I could make this part and keep the strength up. The second thing was to then put a reinforcing rib in this part just to stiffen the part up, and that worked very well. So what's happened is from the original mold I've gotten a thick part, a thin part, and a part with a reinforcing rib before I ever went and made the second mold. Now the second mold, the design has changed just a little bit. As you can see, the part is thinner at the top, a little bit wider at the bottom, and what that does, it allows the toe to lay in the mold a little bit nicer. Now we're ultimately going to move on, and it won't be part of this video, it'll be part of a future video. When we arrive at a design that we're totally happy with here, and we're totally convinced that there'll be a market for X amount of these parts, for instance in the pylon racing market, or in a kit manufacturer, for instance. When we find that outlet for the part, what we're going to do then is have this mold replicated in a machine shop environment out of a billet of Delrin or a billet of aluminum. But you wouldn't want to spend what would amount to be thousands of dollars to make that mold, and now you turn around, oh, the part doesn't work, it bends, it breaks, it's too thick, it's too thin. You want to do all your experimenting with these basic wood molds. until you're satisfied. Now let's say you're doing a custom, because many people that I know are very interested in making their own custom landing gear to their own custom specifications. Well, for a few dollars and a couple of hours, a couple of calls to George Spar, a couple of calls to myself, and watching a video, I don't think there's many people that couldn't make this part. I think you could get 90% of it. Preparing the mold, the big obstacles in the way of making a perfect part. They don't have enough polish on the mold, enough finish, and the Brodack dope has worked so well in that regard. It's just been perfect. These parts, the reflection of the Brodack dope finish is part of what makes these parts really nice. But you also have a mold that right now, there's probably less than $2 worth of material in it. PVA is the mold release agent, polyvinyl alcohol, is relatively cheap, probably in the neighborhood of $4 to $5 for an amount that you'd never use up as a hobbyist. The paint that would go on the mold, maybe 50 cents worth of paint. And you've got the possibility from George Spar, we're going to be getting, and we're going to be making other videos for George Spar in the future, showing some of the other technology that's available to modelers. This is one, I think, the niche that this fills in the hobby is, this is an excellent part. If you're interested in molding, you don't want to start with a B-29 wing. You want to start with a relatively simple part. I think, and you certainly don't want to start with things like propellers of that nature, where you need to have very high-tech resins and oven cures and things like that. These parts, I think an average modeler with average skills, and if you don't have average skills, you'll develop them as you go. It's going to force you to develop some skills you might not have. The time here is probably about 6 to 10 hours to prepare and make the mold, and from that point in time on, you should be able to make one part a day for your own needs, or even if you want to have a little side, sell them to people or whatever. But it's the basic skills, and learning those skills for me took quite a long time because I didn't have access to the kind of video that you're watching. I developed this by watching other people, by calling people. Ed Gallagher, for instance, was one of the people that made this possible. Wayne Triven, Dennis Toth, people that shared their information willingly. So I want to add my name to the list of people that have been very generous in sharing the information. You also want to, in the case I've developed a unique relationship with George Spar, hopefully, that he will be selling some of these products. He'll have some videos available on other molding technology that we've developed over the years. And I hope that's going to be a very symbiotic relationship, and I hope it's going to benefit all the hobbyists in all the events in a way that's very unique. Not many people are doing this. There's only a handful of people that are willing to. I've found many people even try to keep these things secret. You can't find out where to buy the material, the resins and everything, especially when it gets to propellers. But to make this material available so average hobbyists can do this, I think will be a significant gain over what we have now. I'm very conscious, because of the other businesses that I run, I'm very conscious of wasting time. So I'm always thinking in terms of something that can be drying while I'm working on another project. I'm usually running 6 or 8 or 10 projects at the same time, in the same time window. So now that I've taken, I think we made 3 parts out of this mold already. Now that we've made some parts, we know we're within the limit that we set for the weight. In fact, we're well under it. The parts are plenty strong. It's much stronger than the aluminum part. And we've had a chance to think about, do we want to go into some kind of production with this part? Now we want to for sure check over the mold every time to make sure we haven't taken a little chunk out of it or a little piece that would amount to be an imperfection. And I don't do that visually. I try to do that by hand. It's a lot easier on a painted mold. Now what I did with this is I painted it, and the idea being that the black reflects little flaws. There's some little flaws here I have to correct before I lay this up. But you want to, with your hand, just feel for little spots that may be damaged, deteriorated a little bit. If it's okay, you want to take your PVA, and there's several release agents. At the end of this video, I'm going to put on a list of suppliers from sources that are commercially easy to get this material. You want to brush on, again, I cover the whole mold, even the part that, just so if a little bit of epoxy gets on there. Now it's much better if you have the ability. Now my wife has asthma and allergies to this and every chemical on the planet. So what I try to do, now you can see this is beading up real nice. So it means we still have plenty of wax on the mold. But when that first coat doesn't bead up, then I like to re-wax the mold. And part all number 5 is basically raw carnauba. But you really don't want to use Simonizer or some wax that isn't made for that purpose. On a new mold, I think 4 coats are appropriate. You're much better off if you have the ability to spray it. And I always keep this in a jar. Just leave it shut while I'm not using it. And I like to look at that first coat now because it's going on. I want to see that we're beading up. There's a couple of beads here. So I know I still have plenty of wax on this mold. I want to get 4 coats on this before I lay up another part. But now the beauty of this is I can put this aside to dry. By the way, if you have a heating vent in your house, this is a good time to use it. I can take any of my gallon cans, do the same thing with this. Now this one is going to bead up even worse, because this one we haven't pulled parts out of yet. And you can really see the first time you put the PVA on, this is the part of it that, let me get around here and show this up close. This is the part of it that a lot of people get that they're really not comfortable with. You see that PVA isn't sticking to that. So what'll happen now, if you would go to mold on this, the parts where the PVA has fish-eyed up, there's a good chance they'll pull the mold apart and damage it in some way. The way I've dealt with this is a raw waxed part. And I'm just like I'm waxing a car, but I'm using the PVA to pull up whatever little extra wax is on there. Usually in a professional molding shop, you would know from doing this time after time just how much buffing has to be done to get that first coat of wax that you can just let the PVA lay down. Now what it means is we just have a little bit too much wax on this mold. And this is the most, of all the things that you need to develop a skill of, it's the release agent that's going to allow the part to come out of the mold. That's the most critical thing of all. And the thing is, when you have a problem, you want to have some sources of people to call. Materials, I would say the most helpful person is to just contact George Spar and find out what materials are appropriate, what resins, what tow, things like that. You can always call me. I'm always willing to share what I know. There's other people that have specialties, things that they do that they're excellent at. There's people that make propellers like Bill Lee, Wayne Triven, Dennis Toth, Brian Ether. All of these people have a specialty. And I've found almost all of the fellow modelers are willing to share. Some of them don't want to share at all, but you can usually squeeze it out of them. And I guess that's part of the fun of having little secrets. For some people is some kind of a thrill. My thrill in life is to see other people replicating the things that I've done, see them at the field, see them in the front row at the appearance judging, see them winning contests on a regular basis. Or we're just going to have to let this sit. This is probably going to need a little more polishing. You can see now it's beating up a little bit less, so I want to repeat that. Same thing, even if you have to repeat it 2 or 3 times, so that you can get the PVA to lay down nice and flat. If it doesn't lay down, you're not going to have a good bond onto the mold. This is one of the little tricks of getting that PVA to lay down, is one of the things that really takes a little bit of a skill. And like I said before, we've had extremely good luck using Brodac dope. That has been one of the newest things that I've added to my little repertoire of molding tips. Brodac dope is just a great material. It holds a nice polish. The PVA seems to just release from it real nice. See, after 3 or 4 times, we're really getting the PVA to lay down nice. It's always good to put on thin coats. It's best if you can spray it again. 90 psi is good. Put on thin coats, not thick coats. If you spray it, it'll dry a lot quicker. You'll get a little bit nicer finish. But like I said, we have to work around certain constraints in the house. My wife's health is one of them. So we tend to try to keep the odors in the house and the chemicals to a tolerable level, which I guess is a good idea even if you're totally healthy. Okay, that's laying down well now, and we'll give this 4 coats roughly an hour or 2 apart, but you always, before you put the second coat, you want to make sure it's dry to the touch. And the warmer it is in the house, the drier it'll be, or the shop, the quicker it'll dry. If you have a heating vent, it's not a good idea to force dry it with a hairdryer. I haven't found that to work real well. It leaves globs and blobs, but it is real good to get nice thin coats on. Thin coats are what you're trying for. And to not see the beating up of the wax underneath. See, there's just a little tendency left to fisheye. The next coat should go on perfectly smooth. Tricks. You're always going to have flashing, whether you make propellers, you make landing gear, whatever, whether you do compression molding, single-sided molding, whatever you do, what's going to happen is you're always going to have this edging and flashing to some degree. Now, one way would be to take a belt sander and just grind it off. The problem is you create a lot of dust, and it's really, now I don't wear the mask on this tape because I can't talk. I'd have to go back and put the sound in, and it's not possible for me to do that economically. And we're not trying to make high-end videos that you know, nobody can afford to watch. The idea is to keep the cost down. Okay, so what we're going to do is trim this. A blade with 20 teeth an inch is a good way to do that. We're going to trim as much as we can, and the last little bit do with the belt sander. Now you'll notice when you cut carbon fiber, the blade wears out very quickly. That's par for the course. That's exactly what will always happen. It's not a unique thing. Wearing out a lot of blades is very typical. And I try, of course, to wear a mask. Try not to breathe any dust in. Try not to even get little carbon splinters, can be a real pain to get out. And just see how, now if you just were to get a splinter on that, you'd be really in pain for a while. Now the mold leaves these edge marks that are easy to trim. This is real important. If you use a belt sander, you notice I have a shop vac hooked to the belt sander at all times, because you don't want to breathe this carbon dust at any price. And when you're not shooting video, you certainly want to have a real good mask with cartridges on it. To break all the edges, because when a customer gets the parts, what will happen, there'll be little fiber splinters. This is a good tip. You never want to do this with your bare hands, because if you get one of those splinters under your finger, you want to take, and Bob Martens is the one that made me these blocks years ago, sticky back sandpaper and break all the edges. Now, I didn't turn this on because I don't want to destroy the sound on the video, but this is a vacuum bench that's hooked to a, I don't know if we showed this before. This appeared in Model Aviation as one of my little articles that I wrote years ago. We have a video on how to make a vacuum bench. It pulls all the dust because we're working in the cellar of our home. And like I said, with my wife's health problems and allergies, we really like to keep the dust to a minimum. The bench allows that. Allows us to work in a way that we wouldn't be able to work if we didn't have it. Relatively inexpensive setup, by the way. It's around $300 to have a professional one, and then you just need the bench. in this case an old countertop. Notice we've done several different finishes on these. We have the finish from the bleeder cloth, which leaves a rough finish. This one we did with a piece of Mylar. There's several different ways to get a finish on this. Obviously you could sand it. If you were going to paint this, you'd want to sand it down anyway, but you'll notice there's a variation in the side that was going against the Brodac dope is relatively shiny. And just to make a little bit nicer appearance on this, so that the customer, when he ultimately buys it, can either refinish it or just leave it in clear. We leave a little bit of Brodac dope with retarder. Usually 1 or 2 coats will do it. A little bit of Brodac retarder, a little bit of Brodac dope will just really leave a nice finish on this. And boy, when it's clear, you can see the grains of the fibers in there. It really makes a nice appearance. Now on this particular thing, we're waiting to get some aluminum hardware from Micro Fasteners. We're going to make aluminum axles and aluminum nuts. We're going to have those in stock soon for anybody that's already got a set of landing gear and they need to retrofit or they want to go to the aluminum parts. It does save another fraction of an ounce. If you want to buy them on your own, of course, Micro Fasteners, you talk to John at Micro Fasteners and he'll set you right up. Now while that's drying, again remember, we're doing many projects in the shop at the same time. I can brush on. If I was set up to spray, I would certainly spray this. 90 psi, just leave a little Badger gun or a little DeVilbiss gun set up with the PVA all the time. Put the coats on paper thin. Don't go crazy trying to get the brush strokes out. It's really counterproductive. Now see the way that second coat is laying on? There's no fish eyes in it at all, no residue from the wax. When I get the third and fourth coat on this, it should be really nice and we should be able to pop apart right out of here. I tell you from experience, a big mistake is to try to rush the PVA. A lot of times what I would do is it would be late at night. I typically work in the shop late, far past the time average people go home. But what would happen is I would say, oh, I can get one more part out of the mold. Gee, I'll just get that last coat of PVA on. Oh, gee whiz, I'll run off and, you know, I'll try to do it and get going. And you know, I make these plans and I rush it through. Well, not a good idea. Always a good idea to last coat of PVA, let it dry overnight. Even though it is dry to the touch, it's just cheap insurance. And I'm sure people in the trade, the professional mold makers that do this 24 hours a day, I'm sure they know all the little tricks. Keep in mind there are many, many other good release agents. But if you ever have a technical question, George Spar is my main man. He's the one that has most of the information, the technical part of this, and if he doesn't have it, he can usually find out for you. Again, each coat has to be thoroughly dry. Again, I want to stress how important it is to have sources of information, especially when you run into a problem. My #1 man, of course, is Aerospace Composites, George Spar, his wife Barbara, his son Justin. These people do excellent technical work on gliders. They have other videos available that they've made that are excellent sources of information. His address is 14210 Doolittle Drive, San Leandro, California 94577. His phone number 510-352-2022. His fax 510-352-2021. George Spar. Good source for all your resins, all your tow. A lot of the materials. It's always a good idea to get his catalog. Hey, send him whatever. It's a couple bucks for the catalog. Get it. If you're interested in doing molding, it's a great source of information. One of the things you'll need for any molding operation is PVA, polyvinyl alcohol. It's water soluble and it's an excellent release agent. I get mine from Glue Products of Florida, 4015 Georgia Avenue, West Palm Beach, Florida, 33405. Phone number 561-833-1863. The 800 number is 771-1863. The person I deal with is Les, and he's excellent. He has excellent ability to solve problems. The instructions that come on this say apply light coats with a spray gun at 80 to 90 psi, but it can be brushed. Either way, you're going to get a reasonable finish. This is Formula 5. It's a dedicated mold release wax. Just remember, it's really almost a pure carnauba wax. This is available from Florida Glue and obviously from other sources that do fiberglass supplying. Another excellent mold release primer. Sealer and primer for molds. Seal coat. These are all available from Florida Glue along with good technical instructions on how to use them. Another form of release agent that I use from time to time on very small parts like the exhaust manifolds, Pol-Ease 2601. Again, it's another release agent, but again, my first choice for this type of molding would be PVA. That's my first choice. These are all doable products, but my first choice, again, if it can save you some time and spending some money. I've spent thousands of dollars to figure this out. The PVA seems to work best for me under the shop conditions I work under. I might have mentioned that you can dye any epoxy with epoxy dyes. These are available from Florida Glue. They make about 100 different colors and metal flake if you want to make some custom parts. Now, for instance, using carbon fiber, of course, the part is going to almost have a marbly black look. But any part you make with any kind of fiberglass, any kind of epoxy, any kind of polyester resin, you can use these colors and you can make the part have a custom marbled, like a marbled bowling ball look. Now, George Spar sells some excellent resin. We've used this, we've used George Spar, we've used Florida Glue. But you need to find a resin system that's going to work for you. This is one of them that's very inexpensive. And their catalog always is full of a lot of little tips and hints and how to make things work better for you. It's a nice little catalog. I happen to be on their mailing list. The catalog comes from Goujon Brothers, P.O. Box 908, Bay City, Minnesota 48707. Phone number 517-684-7286, and they will send you a catalog for a phone call. By the way, they make a variety of hardeners, quick and slow, so that this resin can be cured in a very quick time for production purposes or have a very long life in the mold. When you're doing your first layups, you want to have the slow hardener so you have plenty of time to work the mold. You're probably going to want to have a whole bunch of these laying around. These come from SIG. Again, the balsa wood that we used came from SIG. It's always possible, just call them up, get a catalog also. These are very handy to have when you're doing any molding operation. Now, the peel ply material I don't have an address on because I got it from Dave Midgley, but I'm sure if somebody out there was really needing some of this bleeder cloth, they could get the information from Dave Midgley. I'm going to try to get that before we finish out the video. This has worked very well, the bleeder cloth, on the parts we've made using the bleeder cloth. You can see the difference in finish. Here's a piece that's done with bleeder cloth, a piece that's done with the Mylar. Now, before we go on to the next part of this video, a couple little things. This is a little repair, and I just used the resin that's left over from making the next part to fill it till it's higher than the surface, and of course I'll block sand that down with the belt sander and then hand finish it. But I'm always able to fix, there's always a chance that you'll have little imperfections. I think there was another one on here. It's not a problem. You just fill them to where they're higher and then block sand them and finish it down. Wet and dry sandpaper in a sink is the best way to get that final smooth finish. Now, it doesn't hurt the strength of the part at all. The carbon that's in here is so tightly packed, it has no negative effect on the part at all. It's strictly a cosmetic repair. This is the label that came on a bleeder cloth, and I don't have an address, but it's PFG Performance Fabrics. Possibly on one of our future videos we'll get the address for that. All of the dope and a lot of the little other hardware that we've used from time to time has come from John Brodak. His catalog is an excellent source for little hardware, and most important for the paint. The paint, the dope, the retarder, the rejuvenator, the thinner is absolutely world class, the best stuff on the market. I think once anybody uses that, they're going to be sold for life. And for mold making, unbelievable. And John's address is John Brodak, 100 Park Avenue, Carmichael's, PA 15320. Phone number 412-966-2726. Fax 412-966-5670. And by the way, John Brodak holds the premier control line contest of all time on Father's Day in his backyard every year. Give him a call for a little free flyer. It's a great contest, a great way to share the world of modeling. Now, as I said in the beginning, I've kind of made this my life's work, making, enjoying, sharing, being part of the world of model aviation. And my catalog is always free to Pampa members. And if you're not a member, join anyway, even if you don't fly control line stunt. But one of the things that I have that's unique, it's unique in all the world, is a list of videos that are in my catalog, the newest of which deal with tune pipe engines, George Aldrich, GMA 50, tune pipes, developing, working on, flying, things that would center around tune pipes. And we are going to be manufacturing some tune pipes on a small scale very soon. Again, our source of information and material is George Spar for that. The videos are available. Anytime you need technical help, it's a phone call, a letter, or an email away, and my email address is windyu@aol.com. But unique in all the world is the building of, I don't think there's anybody else on the planet that has, first off, we have over 700 master videos. We have the actual building of every plane that I've built since 1992. On video, documented on a very thorough, long, detailed, not one step left out set of videos. And we can go back to the Nationals as far as 1987 and capture every flight, every walk of fly-off flight. I think we have them all, including the team trials. We have the uniqueness of the Spitfire and the Seafire that have many molded parts, molded cowlings, molded props, 5-bladed props, landing gear legs molded, canopy molds. All of that available to somebody who really has a yen to learn this stuff. I'm happy to pass it on. The videos are always available. They're very reasonably priced. All the tapes are $14.95 each. We have a list of other videos that we have made over the years that may have an interest, right from the original set of Nobler Construction videos that went back to 1987. We've been in business a long time. We ship out everything the same day, and we are able to go back to late team trials. We're back to the original videos on some of the things like the original VSC contests, things that as time goes by will have more and more of a value to the world of modeling. Now, we even have videos available on how to do your own canopy molding to make the plug, the actual making of the plug. And this was the plug for our Seafire canopy that slid open. With the help of Dave Midgley and his vacuum forming machine, we have a world-class product available to the whole world of modeling at a very, very reasonable cost. The canopies are only $5, and you don't even have to carve the mold or make any of the plugs or anything. But we have a nice little addition to the world of modeling here. We have several other canopies, the Spitfire and whatnot, the original green box Nobler canopy, Thunderbird, Shark, Aries. I don't even have the list here, but all made on a professional vacuum forming machine. Very nice workmanship by Dave Midgley. I've made a lot of the molds. Dave has made a lot of them. They're real quality product, a unique product. We even have the actual vacuum former on one of the tapes and the cockpit detailing. So if you have any interest in this type of modeling skill, this is a modeling skill that we've documented very well on the tapes that are available. Now, this is a mold that we made last year to fit both the Greenbox Nobler and the George Aldrich 1952 replica. You can see the plug that was carved from the original. This of course is all documented on another video. Very easy to make since you have to carve this part anyway. It's really not a lot of extra work to make the mold. And we came up with this little, what I call a garage mold, that this piece can be taken out and then the mold just easily peeled away from the part. A nice little, I don't know how that would sit in the real world of modeling, but it works well for us. And again, look at how simple this is. Very inexpensive, very easy to replicate. These parts, along with a nice little instruction, are available direct from John Brodak anytime. They're in stock. And it makes the building of a Nobler, with a relatively complex part the cowling is, relatively labor intensive. It makes it a very simple operation. We also have a video on how to install it, do the cutouts, and paint it. A very unique, nice little part. I wish this was available when I was younger. One of the advantages of molding parts, you have to carve this piece anyway. You cannot avoid carving it. Once you transfer that shape and that finish into a mold, making these parts over and over and over and over, relatively simple. Once you develop your little skills, and it's very easy to do, and you're comfortable with it, you do a couple of practice parts that won't come out perfect and throw them away, I think you'll be very happy with the world of molding. And just to give you an idea of what the service life of some of these parts are, this plane is 2 years old. Cowling does not have a scratch in it. None of the molded parts have deteriorated, including the canopy. Not one part of this plane has deteriorated as nearly as much as if the part were balsa wood. And it's at least, if not as light as, it's lighter than its equivalent balsa wood part. Plus I can replicate it over and over again. Even the little exhaust manifolds. And the only problem with the little exhaust manifolds is I wore out the mold, and I'm going to be making a new one this year for those little Merlin and little Griffin exhaust manifolds. Again, the same thing on the original Spitfire. All of these models were in the front row, won the Concours Award, and were very competitive flying. Now we're not quite through with our tooling for making tuned pipes. We're going to make a very limited amount for a very special application, but we'll also make the video and list the source of all our materials on that too when it's available. This was a little soft rubber landing gear mold that I made the landing gear that are on the Spitfire and the Seafire, and you can see after all these years there isn't even a crack in the paint. So it's an excellent testament to, and these parts for sure are lighter than their wood components and a lot less work to make. And the reason is you can make these faces much thinner and have much nicer edges. Before I end up this video, I want to show a few things I keep in my drawer, and I have a couple of these drawers. These are my failures. Things that didn't work out as well as I thought. Made a couple of molds for cowls I never really used. When I was making 5-bladed props, I made several of them that really just were not up to anybody's standard, including my own, and I will gladly I made enough of these 5-bladed props at one time. It was making me crazy. These are very labor intensive. The plugs for them were very labor intensive. This is all things that are available on video. Wheel pant molds that I wasn't happy with the shape. Spinner plugs that took hours and hours of machining. Ron Kiefer did a lot of work for us. Extra exhaust manifolds that I had. Geez, I've got a whole bag of things I just wasn't happy with or had air holes or pinholes. But the point here is that you have to be willing to spend a little time, and when you start this, a couple of the parts aren't going to work. You're going to have some problems. You're going to have a few, it's a little learning curve. But eventually, you will be very happy, and I'm sure if you need help, please just give me a call. You can see how big, that's a yardstick on it. This is a 60-inch mold that we made. And that mold, probably the most complex one I've ever made. The plug in the mold is on another video. It's on 2 videos, in fact, that show the mold. This is a future airplane, a future Spitfire that has a 1-piece molded carbon fiber spar from a very high-tech resin that had to be post-cured. That's one of the things that I think might be out of the realm of average modelers, but certainly the video is entertaining and fun to watch. Fun to watch me suffer. Making this cowling is one that we have on video. This is a relatively easy one to make. A little chin cowl. A little thing that's handy if you're going to do any kind of work with fiberglass or composites is set up a dedicated area in the shop where all your resins, all your hardeners, all your molding rubbers, everything is. I have a dedicated drawer for all my fiberglass and tow and resin and all kinds of things that go bump in the night. A nice way to do this is just wait for garbage day. Get an old dresser, paint it white with Rust-Oleum, and set up a little dedicated area. And then all your molding supplies are in one area, and it's easy to keep track of them and keep an inventory of them. Again, thank you for joining us, and please, if I ever can help, please just give me a call. Sharing the knowledge and sharing the information is probably one of the biggest joys anybody can ever get out of model airplanes. And thanks a lot for joining us. Please share the tape with all your friends. And share the information with all your friends. And if they're not your friends, make them your friends. I want to end this video on a real positive note, thanking everybody that has been so nice and so kind to me in my childhood, my adulthood. Throughout my whole life, I've had a lot of good friends in the world of model plane and outside of it that have helped me learn the skills, and it's my job to pass them on. I've made it my life's work. And in the time that I had in the hobby, I think I used it as productively as I could, but I really was able to make a lot of good friends and share a lot of the things that the pluses and the minuses, the successes and the failures, and it's been a wonderful ride. And I want to really again thank everybody that's been so helpful to me over the years. And a special thanks to this guy on the left, John Brodak, who's just been a wonderful friend, and George Aldrich for all his help, all his dedication, and I'm sure his life, the world of George Aldrich. There's just a world of things, and he has been a wonderful help. To thank both of you guys personally. The world of model planes is like a little microcosm of life. The friendships you make, the fun you have. And in the end, you have to leave it all behind anyway. And a special thanks to Big Jim Greenaway for all the help he's been over the years. You remember, we average a new video at least once a week, and the latest catalog is always free. Again, thanks for joining us. See you on another tape.